Okay. Okay, so hello everyone and all teacher, all student all together. Okay, so today see me again about the new lecture that I want to introduce all of you that talking about the linear algebra. Okay, so the linear algebra we know already. This subject we learn it in year 3. Okay, year 3 of mathematics department. Okay, so in year 3 that we learn the mathematics in mathematics department at or UPP. We know already about the subjects that we call the linear algebra. Okay, so the linear algebra I take only one point that that to come to represent all, to all of you today. So we talks about the kernels, the image, and nullity and the ranks of the matrix. Okay, of the matrix. So we know already the matrix. It has a lot of algebra in matrix, or we can say that matrix have a lot of calculation in them. Okay, in them. Okay. So for example, so now if I have the matrix A, okay, if I have the matrix A, so the matrix A we call matrix 3 by 3 matrix. Okay, if I have the matrix A 3 by 3 matrix, it means that it has the row, the number of the row is equal to 3 and the number of the column is equal to 3. So we call that the matrix 3 by 3 matrix. Okay, so A is the 3 by 3 matrix like that. So if you want to find the kernel and the image or nullity or ranks of the matrix A, you have to convert the matrix A by the reduced row echelon form. Okay, so if I take the reduced row echelon form, and then I got the new matrix A in row echelon form. Okay, in reduced row echelon form. So we call that the matrix A, it is in the form that we call that row reduced echelon form. Row reduced echelon form, it means that you have to make the row of the matrix in the column 1 is equal to 0. You have to take it equal to 0 and then apply it equal to 0. So when you make the reduced row echelon form of the matrix A, we got the new matrix A in row echelon form like that. So and then you have to find the pivots column and the free variable column. So the first column, okay, the first column, okay, and the second column, okay. So the first column and the second column, it means that 1 0 0 as a vector. Okay, as a vector. So the vector v1 1 0 0 and vector v2 2 1 0 we call pivots column. So the pivot column, it means that the column that has the number 1 in front. Okay, the number 1 of the matrix in front of their column. Okay, their column. So 1 0 0 and 2 1 0, it means that 1 0 0 2 1 0, it means that the number 1 stand in front of the column. So we call it as the pivot column. So the pivot column, we can find the basis of the image. So the basis of the image, it means that the first column it the same in the first column in the origin of the matrix A. Original of the matrix A. So the first column that we convert the matrix A in reduced row echelon form. So the first column in the row reduced echelon form, it represents to the first column in the original matrix A. So the first column in original matrix A we call the vector v1. Okay, so we call it as vector v1. So the vector v1 and vector v2 in the first column and second column of the original of matrix A, we call it as a basis of the image. So the vector v1 and the vector v2, we call it as a vector linear independent. Okay, we call it as a linear independent vector. Okay, so the vector v1 and vector v2, we call it is a basis of the image of the matrix A. So the vector v1 and vector v2, we call it as the linear independent vector. Okay, linear independent vector. So if we call linear independent vector, so what happens next? Okay, so I will show you next. So take a look. If we observe the third column of the matrix reduced row echelon form, so the third column of the matrix row reduced echelon form 3 4 0. Okay, so the vector v1 or vector v or vector w or vector w 3 4 0, we call it as the free variable column. Okay, free variable column. So free variable column, it means that it is the column that doesn't have the number 1 stand in front. So if we have the number 1 stand in front of their column, it means that we call it as the pivot column. If any column that doesn't have the number 1 stand in front, it means that we call it as the free variable column. So free variable column, we can find the basis of the kernel. Okay, so the basis of the kernel of the matrix A, it takes it out from the free variable column. Okay, so the free variable column, we can find the basis of the kernel of the matrix A. And pivot column, we can find the basis of the image of the matrix A. Is that clear? Okay, so it's different. It different. So I want to show you like that. Okay, about the difference about the pivot column and free variable column. So we can write the basis of the kernel of the matrix A. It's equal to span. Okay, it's equal to span of the vector v1. So what is the vector v1 of the kernel? Like is this. Okay, so it's equal to span of the vector 3 4 0. Okay, why we write in this form? Because the vector 3 4 0, it is a vector linear independent. Okay, it is a linear independent vector. So if it is a linear independent vector, we can write it as a linear combination. So if we can write it as a linear combination, we can write the vector v1 as a span of the vector. So the span of the vector, it means that you have to write, you can write the vector v1 as a linear combination. So if you can write the vector v1 as a linear combination, it means that you can write it as a span of the vector v1. Okay, so if so the basis of the kernel of the matrix A is equal to span of the vector v1. So our vector v1 equal to 3 4 0, and then we have to find the dimension. So the dimension of the kernel of the matrix A is equal to 1. So what happened in 1? It means that we have only one vector that span in the matrix A. Okay, so I can say that the dimension of the kernel, it means that you have to it means that you have to count. Okay, you have to count the number of the vector, the number of the linear independent vector in the basis. So the number of the linear independent vector in the basis, it has only one vector. So it means that the dimension of the kernel of the matrix A is equal to 1. Or we can say that, or we can call that it is the nullity. Okay, so the nullity of the matrix, it means that the dimension of the kernel. So the dimension of the kernel of the matrix A, we call it as the nullity of the matrix A. Okay, so the basis of the image of the matrix A, we can write it as a span of the vector v1 and v2. Why? Because vector v1 and v2, they are linear independent vector. So if they are linear independent vector, we can write it as a we can write them as a linear combination. So if we can write it as the linear combination, we can write it as the span. Okay, we can write it as the form like similar to the basis of the kernel. Okay, so we can write it as the span of vector v1 and v2. So it means that it equal to span of the vector v1 is equal to 1, 1, 2, and vector v2 is equal to 3, 4, 2. Okay, 3, 4, 2. Okay, sorry, I forgot. Okay, so the dimension of the image. So the dimension of the image is equal to 2. So 2, what happened about the number 2? It means that this vector and this vector, it means that you have two linear independent vectors that get from the basis. So the dimension of the image of the matrix A is equal to 2 because of the vector v1 and vector v2. It is the linear independent vector. Okay, so we call the dimension of the image, we call it as a rank. So the rank of the matrix, it is the dimension of the image of the matrix A. Okay, so look at the geometrically. Okay, so we can call it the geometrically. Okay, so the geometrically, it means that it is the or we can call it is the domain function and the image function. So the domain function, because the kernel of the matrix is equal to 1. So the dimension of the kernel of our matrix is equal to 1. So it is the straight line. So if I have the straight line, so it is the kernel of the matrix A. It takes the linear transformation. Okay. If it takes the linear transformation to the image, so the image of the matrix A is two-dimensional space. So why I say the image of the matrix A is two-dimensional space, because I have the vector v1 and v2 span in this plane. Okay, so this is we call plane because we have only two linear independent vectors span in this plane. So we call it as a plane. Okay, as a plane because it's created from the vector v1 and the vector v2 as a linear combination. So if we take the vector v1 to make a linear combination with the vector v2, we call it as a span. Okay, so the vector v1 and the vector v2, it span in the two-dimensional space. Okay, two-dimensional space. Okay, two-dimensional space, or we call it as the plane. Okay, or we call it as a plane. So the image function, so our image function in our exercise, it is a plane because it comes from the vector v1, makes a linear combination with the vector v2, it span in our plane. Okay, so this plane, you see in the picture. Okay, so that is the plane, and the vector v1 and vector v2 expand in our plane. So our image of the matrix A, it is the plane of geometrically. Okay, so that's all for today. I show you about the kernel, the image, the nullity and the ranks of the matrix. Okay, so if have any mistake, please recommend me in the comment below. Okay, thank you so much for take a look. So thank you, bye bye.